Today, we're going to talk about exponential. Yesterday, we did the project and the activity. Okay, and so let's look at on the activity we did yesterday, right? For growth activity, what do y'all notice about the graph? It goes to right. So for growth, the graph increases. Yeah, go ahead. The graph increases. And for decay, right, it's the opposite, right? The graph decreases. All right. And so it looked like, let's see. Do I have it here? Thought I did. Okay. So there's an example of growth and decay exponential function, right? For growth, the red line, the red graph increases, and for decay, the blue graph decreases. All right. Okay. All right. Now we're gonna look at the functional graph that models. I like your fit, Mr. Simpson. Thank you. Have a seat. We're gonna look at the graph. We're gonna look at the function, the equation that models decay and growth exponential function. So that function is y equals a times b to the power of x. Now, I want you guys to get used to, let me make this a little bit bigger. View, zoom, 100. I like to use f of x, all right? Same thing as y, all right? So f of x is equal to a times b to the power of x. Now, what does the x means? The x is exponent. I know you guys are used to, 10 square, right, or 4 cube, where the exponent is a constant. In the exponential, right, the exponent is a variable. And that's a big difference. Next thing you want to look at is b. It's supposed to work. Okay, b is the base. And it's called the growth or decay factor, depending on whether the graph is increasing or decreasing. All right. And the a is your starting value, your initial value, and it's also the y-intercept. Very important. The A is your y-intercept. I'm not sure. Okay, so I want you guys to do now, we're going to look at this example here, all right? We have, go back. Oh, go back. Oh, this right here. I'm sorry. All right. And also, our next test is on Wednesday, 9 December. All right. And this, I will tell you, this 9. And this test is like the delay. It's not hard, but the concept of exponential is kind of difficult. A lot of kids don't get it. All right. So I need you guys to make sure you guys go home this evening and just don't dump memory on this stuff. All right. Are we good? Okay, we can talk about your progress report after this. Are we good? All right, here we go. So I want you guys now, we have this example, f of x is equal to 2 to the power of x. All right? F of x is equal to 2 to the power of x. And we're asked to graph it and find some key features. Domain and ranges, you guys remember those things? Um, uh, the y-intercept, the decay factor, and there's a new term you guys haven't come across it. It's called asymptote. All right, we're going to talk about that. Asymptote. All right. Now we're going to find the y values here. So what I want you guys to do is this: we're going to find the value of the function when x is -2. Now remember, when we did a linear function, if I give you f of x is equal to 4x plus 1, and I ask you to find f of 2, right? Go ahead. How do you find f of 2? Exactly, right? Wherever you see x, you substitute 2. That is 4 times 2 plus 1. Same concept with exponents, right? Where I see x, I'm going to substitute negative 2. That's going to equal 2 to the negative 2. So what I want you guys to do now, go to the calculator, okay? We're going to try to find the value of 2 to the power of negative 2. So press 2. Then I want you to, do I have it still up here? Right here. Okay, press this upside down V, all right? Then enter negative 2. Okay, I'm sorry, 1 second. Press 2, then the upside down V, then negative 2, and then enter. And what do you get? 1/4, right? Exactly. Question? So, okay. So that's going to be 1/4, right? Now try for negative 1, yes. You can't use it on, yeah. I'll show you a trick how to figure this out in a second when you don't have a calculator, right? Okay, so negative 1 is what? 1/2. Okay, 0. Mm-mm. Okay, put this in the memory bank. Any number raised to the power of 0 is 1. Exactly. All right? So any number, or if you have b to the power of 0, that is 1. Anything raised to the power of 0 is 1. All right, so then 1, what do we get? 2 and 2, I'm sorry, and 2, 4, this should be 1, okay? So let's go ahead and plot these points in the graph. So let's see. When x is negative 2, we have 1/4. Now that's going to be really close to the line, right? Negative 1/4 is somewhere around right there, all right? Negative 1 is 1/2. That's somewhere in the middle right here. And then 0 is 1. And 1 is 2. And 2 is 4. All right? As you can see, this is a growth. Now look at the y values. See, they're increasing. So whenever you have a table of values, if the y values are increasing, you know you have a growth function right there. All right? If the y values are increasing, it is growth. If it's decreasing, it's decay. So that's one way you can tell whether the table of values is a growth or decay. Question? All right. Okay, let's look at, okay, let me erase this really quick. Now, what is the y-intercept here on this graph? How do you find it out? Exactly. When x is 0, good point. When x is 0, the y-intercept is 1, all right? Or you can look at the graph where the line crosses the y-axis, all right? Oh, I think I erased that stuff. Can I go back? Yep. And all right. Let me kind of extend this a little bit. All right. So the y-intercept is 1. Okay. We know it's a growth, right? And now let's talk about domain and range, your favorite thing. Okay. Now look at the graph. We want to look at how does the x values for the graph behaves. Now, as the graph increases, right? What happened to the x values on the right side? Increase, right? Just keep on going all the way to positive infinity. Now, on the left side, as the graph decreases, what happens to the x values? Just keep on going to negative infinity. So my domain is going to be negative infinity on the left side, the less than sign. On the right side, it's going to be positive infinity and the less than sign. And then we'll put x in the middle. Right? Or we can use that funny looking R, all real numbers. Okay, so that's the domain. Okay? Now, for this class, Algebra 1, if you're given an exponential function like this, the domain is always all real numbers, unless they put a restriction on it. Okay, for instance, if you're given, let me do this real quick. If you're given a graph like looks like this, and they put a closed dot right there, right, then you know it is not all real numbers anymore because there's a restriction on it. So you got to start right here. All right. If there's no restriction on it, right, if there's none, then you know the graph is all real numbers. Don't forget this, guys, in this class, in Algebra 1. All right. So let's look at a range now. Now, the graph, right, it approaches, as you can see, it increases, right? The y value increases. Now, as you go down, the graph approaches 0, but never get to 0. All right? It gets closer and closer to 0, but never touches 0. So the range is going to be y is greater than 0. In this class, Jacqueline, Charles, Maddie, the range is always y is greater than 0. All right? Hint, hint. So the range is y greater than 0. Okay? Now, let's look at what we call the growth or decay factor. Does anyone knows what when I say proceed, what do I mean by proceed? If I say Joel, or if I say Maddie, right, precedes Joel into the class, what do I mean by that? Maddie came before Joel, all right? Maddie precedes, right? She comes before. So how do we find the growth factor? Pick any number in the y column, any value, right? Let's go with 1. All right, let's go with an easier. I'm going to show you. Let's go easy one. Let's pick 2. All right. Let's pick 2, and we're going to divide it by the number that precedes 2. What number is that? 1. What is 2 divided by 1? So the growth factor is 2. All right. Pick any number in the y column. All right. It could be 4. Divide by the preceding number, the number that comes before it. Divide by 2, and that's 2. That's how you get the growth factor. All right. Now, if the growth factor is greater than 1, we have a growth. All right. Because it's greater than 1, we have a growth. All right. Now, let's talk about asymptote. Asymptote. Now, this is very key. I'm going to go back here. Let's do a quick review. Let's do a quick review. Y equals 3. What does that look like on a graph? Exactly, right? Exactly. It's a line that is horizontal and crosses the y-axis at what point? 3. Good. What about y equals -2? Same thing, right? It's a line that crosses the y-axis at the point -2. Now, what about, Caitlin? What about y equals 0? What is that? Exactly, right? It's a line that crosses the y-axis at the origin, right? And if you notice, it parallel is the same as the x-axis, right? Y equals 0. So I want to get that clear. Now let's go back to this, Maddie. No, the asymptote, right? If you notice, the graph approaches the x-axis, but never touches it. It gets closer and closer and closer. So the asymptote is a line that the graph approaches, but never touches. And in this case, it is y equals 0. Okay? In this class, Caitlin, you're right? in this class, the asymptote is y equals 0. All right? Yes. In this class, for Algebra 1, when you get to Algebra 2, and if you do pre-cal and calculus, you have different kind of asymptotes. But for this class, the horizontal asymptote is y equals 0. All right, guys? Oh, thank you. I was just thinking guys were falling, you know. Y equals 0. Are we good there? All right. It's a lot of information to digest. Okay, let's go on to another one. Yes, a lot of new terms too. Now, let's try this one out. I want you guys to we're going to find the value of the function at these x values. So f of x, so I want to find the value of 2, which is going to equal to 2 times 1/2 raised to the power of -2. So go ahead and punch in 1/2, then to the power of -2, and tell me what you get on the calculator. Yeah. You got 4.
Wait, what is the f of x?
Well, 1/2 raised to the power of -2, right? Is what? It should be 4, right? Right? And 4 times 2 is 8. So this should give you 8. Everybody see that, right?
Wait, what?
If you punch in the calculator, you got 4, right? And 4 times 2 is 8. All right? Everybody see that? So the next one is going to be what now? 4, right? Huh? Huh? The next one is going to be 2, right? Because 1/2 raised to the power of 0, right? For this one, I'm going to f of 0 is going to equal to 2 times 1/2 to the power of 0. But we know anything raised to the power of 0 is 1. 1 times 2 is 2. And then this one is going to give me, should be 1, right? This should be 1 right here. And this one should be, no. What is 1/2 raised to the power of 2? Somebody tell me.
Wait, isn't that 1/2? That's what it did on the
Right here? This is 1/2? Okay, I think you got that right, yeah. Yeah, just trying to do some mental math at the same time. Okay, don't do math. All right, so let's plot these points on the graph now, right? Now, if you look at this now, my y values are decreasing. See that? 8, 4, 2. So what kind of function do I have? Growth or decay? Decay, right? So we know right off the bat that this is decay because my y values are decreasing. All right. Now, so let's plot this now. -2, 8 is going to be right here. -1, 4 is going to be right there. 0, 2 is right there. And 1, 1, that's right there. And 2 and 1/2 is somewhere in the middle right there. Okay? So that's a decay right there. Now, what is my domain? Look at this graph and tell me what my domain is. Which is? Exactly, right? All right, my domain is going to be negative infinity, positive infinity right, my less than sign, and or I can use the all real number sign. Huh? Unless they put a restrictions on it, where you have the dot. Yeah, exactly. If the dots are not there, then it's going to be all real number. Yes, yes. Well, I want you guys to think through it. You see, like, so you think through it. That's what I want you to do. All right. So my horizontal asymptote now. Okay, what is my range? Which is y is greater than 0, right? Because the graph never touches 0. Okay. What's my y-intercept? Everybody see that, right? When x is 0, y is 2. And what is my growth factor? My decay factor, I should say. Remember, pick a number in the y value and divide it by the preceding number. 1/2, right? Pick any number, 1, divided by the number that comes before it, which is 2. So that gives you 1/2. All right? Or if I go with 2, pick 2, divide it by the number that comes before it, which is 4, that gives me 1/2. So again, you can tell from the growth factor, right? From the, okay. And what's my asymptote going to be? Y equals 0. Now, they may ask you to write the equation, all right? So, not here, but they're going to ask you. Now, look at this now. Let me get some more space. Let me erase this. All right. So, remember, the standard form for asymptote for exponential function, right, is y is y is equal to a times b to the x. So we're going to write the equation for this. We know x is going to be the same. That's the exponent. Now, b is my growth factor, right? So what is my growth factor? So b is going to be 1/2. A is my y-intercept. Thank you. So A is 2, right? So my equation is going to be y is equal to 2, parentheses, 1/2 to the power of x. So that's how you write the equation. Okay. Maddie, you with me? A lot more. All right, guys. We're good? All right. Man, you guys did better than last year. Last year, they struggled on this stuff last year. They struggled. All right. I'm going to skip this one. I can't do all the ones on the paper. I just won't have time to get through stuff. What I'm going to do, I'm going to post the answer keys to everything so you guys can go back and work these. And okay. Now let's look at this here. So the domain of an exponential function b to the x is the domain of a function of x is equal to b to the x is, what is domain going to be? All real numbers, right? All right. So all real numbers are negative infinity is less than x is less than positive infinity, right? And the range is going to be y is greater than 0. Now the y-intercept of the graph, I don't like the way this is worded. The y-intercept of the graph is always 1, right? Of bx is always 1 because any number except 0 raised to the power of 0 is 1. All right. And the graph of f of x equals bx is always the horizontal asymptote at the, because I think this should be y equals 0 because the graph gets closer and closer to the x-axis but never touches it, but never touches the x-axis. Okay. All right. Yeah, it's what it's saying that the graph, right, has an horizontal asymptote of y equals 0 because the graph approaches the x-axis but never touches it. That's all it's saying. Visually, you can see what they're saying right there. Okay. And then if the growth factor, right, is a fraction, then we know it's going to be what? What kind of graph is going to be? Decay, right? If the growth factor is a fraction, right, it's going to be a decay. And if it's greater than 1, it's going to be a growth. All right? So, all right. Can I move on here? How much time do we have? All right, here we go. Now we're gonna solve this without even graphing it. All right. Okay. What is my y-intercept? 4. What is my growth or decay factor? Everybody see that, right? Take a number and divide it by the preceding number, 36 divided by 12. Good. So that's 3. It is a growth, right? Because the growth factor is greater than 1. So that's a growth right here. And if you look at the y values, they're increasing. All right? Okay. What is my asymptote going to be? Y equals 0. All right? I mean, we can plot it. All right? And what's my range going to be? And my domain? All right, negative infinity less than x less than positive infinity are all real numbers, okay? And we can plot this. Let's see. When x is 0, we have 4. 1 is 12. And 3 is 36, which is off the graph. 3 is 36. 1, 2, 3, somewhere up there, all right? So I can see that the graph is coming down. And if we keep on going, it's going to look like, well, it doesn't cross it, doesn't touch it, but okay. Okay, I want you guys to do this one. Give you 2 minutes to. Oh, okay. No, to go back. Oh, the equation. Ah, thank you. Thank you. What's the equation going to be? Anybody? Y is equal to 4 parentheses 3. Everybody see that? Maddie, you with me? You look tired. I know Caitlin is tired. Is everybody with me? Good. See that? All right. Remember, you got it. Miss Murray is very incoherent right now. All right. Okay. So remember, the standard form is y is equal to a times b to the power of x. We know that the y-intercept is 4, so that's a is 4. The growth factor b, right, is 3, right? So that's 3 to the power of x. All right, so that's how we got that. All right. Now I want you to do this one for me. Let me do attendance and take a sip of my coffee, and I'll come back. All right. You already done? What you can do is check your answer on this one. Yeah, you actually do. What are you struggling with? Uh-huh. What graphing? Oh, okay. Oh, inequalities. Okay. Huh? Yeah, for this class, what we're doing right now, unless there's restrictions on it, yes, it's gonna be the same. Okay, who am I missing? I have 3, 5, 7, 10, 12. Second period. Thank you. Okay, let's see. Richard is not here. So, no, it's not. Okay. All right, got everybody else. All right. Okay, so tell me who's going to give me my answers for this. Okay, so what's my domain going to be? Negative infinity is less than x. Okay, that's all you're gonna say? Okay, what's my range, Jacqueline? Outstanding, Jacqueline. Good. Okay, my asymptote is gonna be, Preston, y equals 0. That's my asymptote, y equals 0. And my y-intercept, 4. Is this a growth or decay? All right, you can tell because the graph, the y values are going down, decreasing, so that's a decay. And what's my growth factor? Okay, take any number, right, and divide it by the number that comes before it. So 1 divided by 2, that gives you 1/2. And what's my equation going to be now? Good. All right, because my y-intercept is 4, that's the A. My growth factor is 1/2, which is the B. Okay, to the X. Man, you guys are on it. All right. All right. We're gonna do. Let's do this one. All right. Let's find my domain, my range. Give you guys a minute to look at it. What's that? No, an arrow sign just means that there are no restrictions on it. There are no restrictions. Good point there. All right. And you just give me an idea on this one. I'm going to modify this one a little bit. All right. All right. So let's look at this one. What's my domain going to be? All real numbers, right? I'm just going to use the. I want you guys to get practice writing this because some kids just, you know, less than negative infinity. So I'm gonna keep on doing that, or all real numbers. All right. My range is gonna be y is greater than 0. All right. As you can see, the graph never get to 0. All right. It approaches 0, but never gets to 0. All real numbers. It just points on the graph to help you. Yeah. Okay. And the horizontal asymptote is y equals 0, and my y-intercept is 1. That is 1. That's correct. My y-intercept is 1. What about my growth? Is the growth? Yeah, that's the growth. And okay, here we go. What's the growth factor? Yes, and that's why Charles, you asked why do we have dots? It's to help you figure out the growth factor. All right. So we got 3. Pick a value on the y axis. That's 3. That's this one. And we divide it by the next y value, which is 9. Oh, I did it wrong. I did it backwards, right? Yeah. Should be 9 divided by 3. All right. The growth factor is 9 divided by 3. All right. So that's my growth factor, 9 divided by 3. All right, guys. Question? Yeah, go ahead. All right, guys. So I think huh? Yeah. Oh, the equation. Thank you, Miss Murs. So what's my equation, Miss Murs? Y equals, okay, the 1, okay, which is 1. So we're gonna leave that off. 3 to the x. All right. Now here we go. Now let's put some restrictions on this. Now, what if this was a circle, um, right there? Okay. So what's my range gonna be? We just can't put no. We gotta put something in it. Yeah, I mean, my highest y is gonna be 9, but how do we write? Yeah, the highest value for the y is gonna be 9. I think you was like, yeah, you in the right direction, but say again.
What were you saying?
if I put a restriction on the graph, right? Right. So this is my restriction right here. So what's my range going to be? All right. I'm going to have 9 on the right side, right? But this is going to change. It's less than now. That's what I'm saying, right? It's going to be less than or equal to 9, right? What about this side now? What about, right? 0's on the left side, right? So it's going to be less than, right? Less than, greater than 0, less than or equal to 9. Did I lose you guys on that one? Huh? What's that? The domain stays the same. Yeah, domain stays the same. I'm just saying if we have I'm putting a restriction on the range now. Oh, I'm sorry. No, the domain is not the same because the graph stops right here. So what's my domain going to be now? Well, the x value goes all the way up to right here, right? This is where the x value stops at.
Oh, infinity and less than 2.
Exactly. So this is going to change to 2 now. Yes, negative infinity to 2. All right. So that's my. What are you confused about? Okay. All right, are we good? All right, guys. So remember, if there are no restrictions on it, it's all real numbers for the domain, right? And for the range is y is greater than 0. But once you put restrictions on the graph, you see how things change. I just want to make sure you guys are aware of that. Okay. All right. I think we did better today than we did last semester. All right. Tomorrow we're going to dig deeper, add more word problems and stuff like that. Yes, yes, word problems. Question? Oh, yes, yes, yes. Okay, let's go back. Good point. Now, let's go back to where did we do this at? Okay, let's go back to this one. Okay, I'm gonna show Joel something real quick. I'm gonna erase some of this stuff right here, Joel, to get some more space. All right. Um, okay. That's not the one I want to work with. Let's go to this one. This one. Let's go with this one first. Yes, go ahead. All right. So f of x, Joel, all right? F of x is equal to 2 to the x, all right? And we want to find a value of f of negative 2. That's going to equal to 2 to the power of negative 2, right? Now, to solve this, right, the negative 2 means reciprocal. So I can rewrite this as 1 over 2 raised to the power of 2. So what happens to the negative sign now? It goes away. So what is 2 squared? 2 squared is just 2 times 2, right? That's going to give me 1 over 4. So that's like a. Let's do another example. Um, no, this doesn't have the. Oh, what you could probably do, see if you can pull up the scientific calculator. You know what I'm talking about? So you can pull up the scientific. Okay, let me stop this right now. Let me stop this recording. Hold on.